Hello dear children, in the previous classes we discussed about the concept of projectile motion, horizontal projectile motion and inclined projectile motion, and even we discussed the parameters related to the horizontal projectile motion and inclined projectile motion. Links will be given in the description. Just go through those videos to get a command and to get a concept of a previous knowledge so that you will understand today's class. Okay, fine. Especially children, in today's class we will be discussing about the projectile motion on inclined plane. This is very important for a examination point of view. So what is the topic today we are going to discuss, dear children? Projectile motion on inclined plane. So look at here. So here is a horizontal, okay, let us say okay, and here there is a inclined plane. There is a inclined plane such that theta is the angle of inclination. Try to understand, it is not angle of projection, it is a angle of inclination. So this is the inclined plane and the horizontal plane. Now for suppose here, the children, in this what we can say projectile motion inclined plane, we have two cases. One is down to top, we are throwing the projectile. Projectile is, it's the body is projected, okay na, from down to top and top to down. So we discuss today only down to top case only. So top to down case we'll try to cover in a next video. Okay, fine. So here let us say that the body is there, let us say projectile. So it is projected, okay na, such that here children, such that here alpha is the, let alpha is the angle of projection, let alpha is the angle of projection, and here projectile is projected with an initial velocity of u. So u is the initial velocity of the projectile, alpha is the angle of projection, theta is the angle of inclination. Don't get confused. Dear children, we know that projectile motion is a two-dimensional motion. Hence, velocity of the projectile can be resolved into two rectangular components. So, if you want to resolve the vector, what we can say velocity into two rectangular components, first we must define what is the x-axis, what is the y-axis. Children, for suppose here this is x-axis and here is the y-axis. We know very well. Okay now. Of course, can we just rotate this at an angle? We can rotate. So x-axis you can take like this, then this is going to be y-axis. Okay now. So both must be mutually perpendicular to each other. That is actually the concept of the x and y-axis. Okay. Now why is at this point, now this inclination we are going to take as a x-axis, this inclination. So let us say this is origin O, okay now, and this will be a negative x-axis, and it is a positive x-axis. As it is the x-axis, obviously the line, the axis which is drawn perpendicular to it is going to be a y-axis, right? Okay. So now this is going to be a y-axis. Try to understand. So this will be negative y-axis and this is going to be a positive y-axis. Okay, fine. Now let us resolve initial velocity of the projectile into two rectangular component. One is along the horizontal component ux, this will be uy. Okay. Now children, we know that at every point acceleration due to gravity, means the acceleration due to gravity will be acting vertically downward direction. At any point you can take, either at a point of projection or here, anywhere. Okay. So its direction will be downwards only. This is a acceleration due to gravity, and this is make an angle theta with the horizontal axis, and okay, now it is make an angle theta with the negative y-axis. Now as acceleration due to gravity is a vector quantity, let us resolve into two rectangular components. This is going to be a gy, this is going to be a gx, and the children, and this component is going to be a cos theta component, right? Because it is making angle theta. So this will be g cos theta, but minus y minus along the minus y axis, and this is going to be, let me write here, gx is equal to minus g sin theta. Okay, so hope you understood how we resolved. So let us write here. So along x-axis, what are the components? Along y-axis, what are the components? Then only we can understand other concepts. So along x-axis, dear children, ux is equal to u cos alpha. It is going to be right. U cos alpha, whereas uy is equal to u sin alpha. Whereas here gx, this will be minus g sin theta, whereas gy is equal to minus g cos theta. So now with this information, now let us discuss the components related to the what? Projectile motion on an inclined plane. First, let us try to calculate the time of flight. Means the time taken, let us say O, it is A. So the time taken to reach this point A is, we can call it the time of flight. Means the time for which a projectile remains in air is called time of flight. Okay. So whenever we are discussing a time of flight, children, yes, you need to take the vertical motion, because in a vertical direction it is a covering, right? Vertical motion we need to take. Okay. So first component we are going to discuss what? Time of flight. So capital T. So children, we know that S is equal to ut plus half a t square. As it is a vertical motion we are taking, this is going to be sy, this is uy, it is ay. Sy means what? In a vertical direction, displacement curve will be, finally it is coming to this point. So there is no displacement in the vertical direction. So displacement in the vertical direction is 0. Okay. So here 0 is equal to uy is going to be u sin alpha, and time of flight will be t, and ay is going to be, that is nothing but gy minus g cos theta. So minus into place minus, okay, that is g cos theta by 2 is there as well, and here is a t square. Okay, fine. Now here we can take a okay, this term you can bring this side. So then it is going to be 1 by 2 g cos theta into t square is equal to u sin alpha into t. The t square gets cancelled. So we want an expression for t, right? G cos theta to get this side. So then t is equal to 2u sin alpha by g cos theta. So children, this is a final expression for a time of flight, where in the case of a body, in the case of projectile motion on an inclined plane. So this can be written like this, u sin alpha is nothing but uy. So it is a 2uy, and g cos theta is nothing but gy. I am talking about the magnitude, not here. Don't think about plus minus, magnitude. So that is gy. So this is a expression for a time of flight in the case of a projectile motion on a inclined plane. On where, dear children? It is a inclined plane purely. Okay, copied this. Okay, fine. Now we are going to talk about the maximum height. Maximum height means, yes, this is a maximum height. So at this point, actually at a maximum height h, the final means vertical component, the final velocity of the vertical component at a maximum height is going to be 0. This point you should remember. Okay, so I think I need a space. Can I erase this portion? Okay. Okay, now it is not required. Anyhow, we have a components along x-axis and a component along the y-axis. So now what are we going to do? We are going to derive the expression for maximum height. What is that, children? Maximum height. So here let us take here expression v square is equal to u square plus 2as. So this is vertical motion we are going to consider, because the height is nothing. So height of the projectile is in the direction of vertical, right? Okay, fine. So anyhow vy is 0 at a maximum height, and the uy is u sin alpha, square is there. So this is going to be a u square sine square alpha. Ay is minus g cos theta, minus into plus, minus 2g cos theta, and the s is the displacement, that is nothing but displacement called in vertical direction is the maximum height. Bring this term this side, so this is 2g cos theta into h is equal to u square sine square alpha. So here h is equal to u square sine square alpha by 2g cos, will come this side, 2g cos theta. So this is the expression for a maximum height. This is the expression for a time of flight, and this is the expression for a maximum height. Now the third what we can say parameter which we are going to derive for what actually? Range here. So on horizon, of course here I is right. So on the inclined plane it is covering some horizontal distance, it is covering some horizontal distance, right? That only O to A we can call it as a horizontal range. So to discuss about the horizontal range, we need to consider the horizontal motion but not a vertical motion. Okay, hope this is copied. Let me just take this place. Okay, fine. And children, these are very important. Even I said that in next video we are going to discuss the down to what we can say top to down, right? There also we should remember these components. Okay, fine. So now the third parameter we are going to discuss is range. Now we'll discuss range, and we also can see when this range is going to be maximum. Okay, fine. So we know that here s is equal to ut plus half a t square. So this is horizontal direction, ux, ax, and here this t is going to be a time of flight. Why? Because the range is what? The total distance covered in the horizontal direction. Further, the time taken will be time of flight. The time of, in a time of flight t, how much distance it can cover, which is equal to the horizontal range, that is equal to the range. Okay, fine. Now this is going to be r. Okay, ux is u cos alpha, u cos alpha. Time of flight, how much we got? 2u sine alpha by g cos theta. In the place of this is time of flight I am writing, and here ax is what? Minus g sine theta. So plus into minus, it is minus only 1 by 2 g sine theta into t square. So this term whole square we should write here. Okay, can I erase this maximum height? Okay, fine. This is not required for us now. So fine, just last we'll try to just write all together. Okay, so this is going to be a 4u square sine square alpha. Directly in the place of t I am substituting time of flight mode, don't get confused. Will be g square cos square theta. 2 1s are 2 2s are. Okay, now u into u square. This will be so 2u square cos alpha into sin alpha by g cos theta. Now this entire term I will multiply with the cos theta, divide with the cos theta. Both will get cancelled. You may get one doubt, sir, why are we doing that? Just wait a second. Okay, this cos theta into cos theta square, right? Yes. So I will write here. This will be cos theta into cos theta square minus, now look at here, 2u square, where is g? Okay, g squarels will get cancelled. 2u square sin theta sin square alpha by g cos square theta. Now look at here, why I multiplied and divided here. Look at here. Now g cos square theta, g cos square theta, common, right? And here 2u square sin alpha I can take as a common. So our idea is this only. 2u square sin alpha we can take as a common by g cos square theta. Then the remaining term will be cos alpha cos theta, cos alpha into cos theta minus, here in sin square, one sin was taken outside, so one more sin will be there, sin alpha into sin theta. So now it is in the form of cos A cos B minus sin A sin B is nothing but what? Cos A plus B formula. So are you able to see? Let me just check. Yeah, okay, let me take this space here. So now range is equal to, so we are getting 2u square sin alpha by g cos square theta into, okay, it is nothing but cos a plus b. Cos a plus b means what? Alpha plus theta. So children, now this is a expression for maximum range. Expression for a maximum range. This is an expression for actual what? It is a maximum range. Now when this range is going to be a maximum, so for a maximum, children, did you remember the condition? What is that? If equation is in terms of y, then dy by dx. If y is changing with respect to x, then dy by dx is equal to 0. Or else, if x is changing with respect to y, if x is changing with respect to y, dx by dy is equal to 0. This is a condition for maximum. So according to this, now dr by it is d alpha. Why? Here theta is not a variable. Theta is angle of inclination. It's a constant. Alpha is a variable. Alpha, angular projection is a variable. Okay, fine. So this must be equal to 0. This must be equal to 0. So first need to find the differentiation of r. So here, as we are differentiating r in terms of alpha, theta component will be constant. So this entire term 2u square by g cos square theta remains constant by d by d alpha. So it is sin alpha into cos alpha plus theta. Okay, so here it is u to v. So uv method we are going to apply. So I think we need a space of, okay, not required here. Let us try to here only. Okay, so look at here, children. So anyhow this going to be 0. Okay, so this entire term will go this side, will become 0 only. Okay, now fine. So now if you can see, so you keep a constant now, sin alpha. So if you can see d by d alpha for cos theta, if you can, this will become minus sin theta. So this will become minus sin alpha plus theta, and here plus cos alpha plus theta, cos alpha plus theta, and this sin alpha, differentiation of sin alpha will become cos alpha. Cos alpha is equal to 0. So now this we can write like this. So cos alpha plus theta into cos alpha minus sin alpha plus theta into sin alpha is equal to 0. So this is cos a cos b minus sin a sin b. Again it is a cos a plus b. This is nothing but a, it is nothing but b. So now it is cos alpha plus theta plus alpha is equal to 0. This will be cos 2 alpha plus theta. For what value of cos is going to be 0? Cos 90. Cos 90 is nothing but cos pi by 2. Cos pi by 2. So as cos 2 alpha plus theta is equal to cos pi by 2, it can be written as 2 alpha plus theta is equal to pi by 2. And here 2 alpha is equal to theta will go this side, pi by 2 minus theta. Okay. So have you copied this portion, just this portion? Hope you have copied 3, 2, 1 this portion. Okay, almost we have completed the concept. Okay, now so we got 2 alpha is equal to pi by 2 minus theta. So alpha is equal to 2 will go this side, will be 1 by 2 into pi by 2 minus theta, or you can write alpha is equal to pi by 4 minus theta by 2. So dear children, with this much angle, a body should be projected on the inclined plane, so as to have a maximum range. So alpha is equal to pi by 4 minus theta by 2. So dear children, so this is a concept of what actually projectile motion on inclined plane. So now let us list out. Can I erase this? Okay. Now let us list out the parameters whatever we obtained in the case of a projectile motion on an inclined plane. So first one is time of flight. Time of flight, how much we got? 2u sin alpha by g cos theta by g cos theta. Second parameter is maximum height. This we got as a u square sin square alpha by 2g cos theta. So third one, range. R is equal to, we got the 2u square sin alpha into cos alpha plus theta by g cos square theta. But here if alpha is equal to pi by 4 minus theta by 2, then R will become maximum. R will become maximum. And the children, here let us try to understand here. If in all the cases, if theta is equal to 0, children, theta is equal to 0 means what? Theta is equal to 0 means what? It is nothing but the projectile motion, and projectile motion means body is projected from the horizontal only. With a, is the point clear? So if angle is theta is equal to 0, I mean sorry, not theta is equal to 0. Okay, then what happens? This will become 2u sin alpha by cos 0 is 1 only, g. So now this is going to be u square sin square alpha by 2g. Okay, now this range will become what? So it's a completely, this is going to be 1. Okay, now this is going to be 2 sin alpha, and here cos alpha will be there. 2 sin theta cos theta sin 2 theta. So this will be u square sin 2 alpha by g. So if you can see, these all are the expressions for what actually here is horizontal, and projectile is projected with initial velocity u, so that make an angle alpha. If alpha is a angular projection and projected from the horizontal, but not means when theta is 0, when the angle of inclination is 0, these all the cases are going to be a normal case, whatever we learned, where the body is projected from the horizontal surface with a velocity of u, and alpha is a angle of projection. Okay children, so this is actually today's topic, where we discussed about the projectile motion and inclined plane. But as I told that here we have two cases. The first case is what actually down to top. In next class we are going to discuss top to down. That is going to be very easy, because already just we got a command, right, how to do and all these things. Okay, so with this today we are going to end our session. Okay children, thank you so much, all the very best.